Okay, so we have the concept of a thing called an availability set. That's just a container. And if we put VMs into this availability set, let's put one here and one here. I think pretty much everybody in the industry now knows that this VM will be hosted on a host, which is in a rack with many other hosts. There's lots of them. So let's draw that guest in there. Let's have that. That's the guest operating system. And then what it means is that this one will be on a different rack. Let's go back to the original color. Here's a different rack in a completely different part of the data center on a different host, which is on different networking, power, fault domains is what they're called, to keep these things separated from each other. So let's put that host there. And so that's for faults. So if one of these machines, if one of these racks was to fail, then it doesn't matter, because the other rack has got a host in it. Sorry, has got a host which is running a guest, which will continue to provide the service. And the service would go through a load balancer. So we'd have a load balancer here. And that could be either passing the information through a PIP to the public on the internet, or it could be connected to a VNet. And from there could be in turn connected to your own internal corporate network. Okay, that's pretty straightforward. I think everybody knows that. And that gives you a 99.95% availability service level agreement. Okay, but what happens if you've only got one VM? Now, if you've only got one VM, then for a single VM, it goes to 99.9% SLA. Okay, does that VM have to be in an availability set? Yes or no? No, it doesn't need to be in an availability set. It does need to have premium storage. So if it's a VM that doesn't qualify for premium storage, or you haven't got it running on premium storage, then you won't get this 99.9% availability guarantee. Okay, let's get rid of this picture now, because I think this is something that nearly everybody knows. And let's talk about single VMs. Okay, so you've got a 99.9% availability guarantee, and that protects you against unplanned. Let's use that. Let's highlight that word. Unplanned downtime. And there's a calculation which talks about, how they work out the total availability, what the availability was in a month in minutes, and how those minutes are calculated. If you just do a search on the internet, you'll find that. Sorry, that says unplanned there. Look, let me put two N's there. You kind of get the idea. Okay, so unplanned downtime. So that means that when a failure occurs. But sometimes Microsoft needs to do some planned downtime. Now you don't get any service credits or anything like that for planned downtime, and the reason for that is because we will inform you if there is some planned downtime. The typical reason for planned downtime is because of a host or underlying infrastructure update, or just general maintenance. Okay, so that is the typical reason for that. Now, I did say here that we will inform you if there's going to be some downtime. If you're going to be subject to some downtime, you will get probably between 5 and 9 days worth of notice that some maintenance is going to be performed on your VM. if it's 2 VMs in an availability set, then what will happen is we'll do the update on one rack, and then we'll do an update on another rack, and so you won't be impacted. But when it's a single VM, you will possibly be impacted by it. Okay, what does that notification look like? Well, let me show you one that I've got in the past, and it goes to. Sorry, let me just tell you who it goes to. It goes to the global administrator of the subscription in which the machine is going to be impacted, and any co-admins which that global administrator has created to help him with the job of administering that subscription. So let's have a look in here. That is the thing. So it says upcoming maintenance may impact single instance deployments of Microsoft Azure virtual machines, and it gives you all this kind of stuff. This email is actually from up here, look, the 18th of the 3rd, 2016. So this is basically just over a year ago. That's the last time I got a message, was over a year ago. So that gives you some idea of how often we're doing unplanned maintenance that has an impact on people. It's very rare these days. Let's go down here. We can see here all these different regions and when the maintenance window is. Tells you, what time it starts and what time it finishes. And then we go down here a little bit further, and it says I have a machine. It's called LB Planky, and that is the machine that is going to be impacted by this. Okay, so I am proactively informed. Now let's have a look. It's 18th of the 3rd, 2016 was when the email was sent to me. Now this was provisioned into, I believe, North Europe. Well, it was North Europe, I know it was. And if we have a look at North Europe, was going to be impacted on Sunday, March the 27th. Sunday, March the 27th. So that has given me from the 18th of the 3rd to the 27th of the 3rd, 9 days. Gives me 9 days worth of notice. So that's why I said over here that you'll get somewhere between 5 to 9 days notice. I mean, I do believe that some customers might even get 10 or 11 days notice. But you will be informed that that is going to happen. Okay, park that in your mind for a little while, and let's talk about what qualifies as unplanned downtime. So let me get rid of some of this. Now, what used to happen in the good old bad old days was around about every 6. Let me get the brushes back again. Get the right color. Around about every 6 to 8 weeks, this was pre-March 2016, something like that date. I'm not going to sort of make a commitment there because I can't see what other people have received, but you can see what I've received. So pre-March 2016, every 6 to 8 weeks, we were doing updates to the infrastructure. So if you had a single guest, a single OS, that was running on a host, and let's just imagine that we wanted to patch that host. Well, it's not possible to run a guest on a host where the update requires the host to do a reboot. So if we're going to recycle this this machine, you get the idea. If we're going to recycle that machine, recycle means reboot, then obviously this guest has to shut down as well. And that used to be around about 15 minutes worth of downtime. But of course it was planned downtime. So you didn't get 15 minutes worth of unavailability included in your metrics for that month's worth of availability. Now, one of the things that Microsoft worked really hard on is when we now have patches and these kinds of things which need to be applied to hosts. Let's grab those patches, let's apply them onto that host. These days, mostly they don't require a reboot. So let's get that back again. So mostly these patches that are applied mostly don't require a reboot. However, some patches may require a reboot, and that's going to involve 15 minutes. One of the things that's been happening also fairly recently is that there's a technology which is called memory preserving updates. Memory preserving updates. So let's just see if I can sort of make up what this diagram is going to look like as I go along. What that means is you have a host. Let's get the brushes back again. So you have a host machine, and in that host you've got a load of RAM, and you've got disks, and you've got guest operating systems. And let's imagine that that bit of RAM is allocated to that guest. Let's imagine that this bit of RAM is allocated to this guest, and let's imagine that this bit of RAM here is allocated to this guest. Let's get the colors right there. So the orange RAM is for that guest, and the red RAM is for that guest. But the host itself has got its own operating system. Let's draw the host's operating system, and let's draw that in just there. The host OS. So what we can do with memory preserving updates is, as long as we can preserve what's in memory, we can perform an update on the host independently of what's in memory. So what we'll do is we'll basically pause these machines, and we'll maintain the state of memory at the point that we pause them. You could say it's a little bit like putting the machine, like putting your laptop to sleep, isn't it? All that does is it provides a small amount of power to the RAM, so that when you fire the machine up again, it carries on from where it left off. So that's what we'll be doing in these situations. Do you get informed about when this happens? First question, how long is the pause? The pause is, we're kind of saying it's kind of less than 30 seconds. Actually, a bit more sort of accurately to say is really to... Let me come back to that point in a minute. Do you get informed about this? No, you don't get informed about it. So your machine is going to pause. That means it's going to freeze for 30 seconds, and then it's going to carry on again. The host update will be performed. The host will then reboot, carry on working, and RAM will be loaded, or RAM will be preserved for your machine. Okay, so we don't inform you about this. Why not? Well, because I've said less than 30 seconds there. Actually, the time period for these kind of host memory, these memory preserving updates is less than, let me get these brushes again, is less than the TCP, the default TCP timeout value for most of the clients that are going to connect to you. So I believe pretty much most Windows servers, most Windows clients have a default TCP timeout of 3 seconds. And then they have a default retry of 5 retries. But they do this, I've forgotten what the phrase is now, but there's a phrase for where the amount of time that is provided between each retry, it doubles each time. So we've got 5 retries. We do 3 seconds for the first retry, and then it doubles to 6 seconds, and then it doubles to 12 seconds, and then it doubles to 24 seconds, and then it doubles to 48 seconds. So it meant we had one delay of 3 seconds, one delay of 6, one of 12, one of 24, and one of 48. So let's add that up. 48 plus 24 plus 12 plus 6 plus 3. That's 9, 10, 11, 15, 23. Put down 3, carry 2. So that's 4, 5, 6, 7, 8, 9. So we're talking about TCP timeout of around about 93 seconds, which is what? 1 minute and 33 seconds. And we're talking here about timeouts of less than the TCP timeout, and we're talking about typical values of around 30 seconds. So you're not, in most cases, you're not even going to have TCP connections dropped. What it really means is, if you've got somebody who's connecting to your thing, your server, and they've got a TCP connection open, and HTTP is based on a TCP, and each HTTP request is a separate TCP connection. So the TCP connection gets made. You've got 93 seconds if there's a failure of some description for this to go through retries. 1, 2, 3, 4, 5 retries, and because this server, because its memory will be back in line and working again after 30 seconds, all that the user is going to notice is it took a bit longer for that page to download. Or if they're doing RDP, it took a few seconds for that bit of the screen to be rendered. Or if they're using some other type of protocol, it took a bit longer for that data to appear on the screen. It took a bit longer for the stuff to appear. But mostly, nobody's going to be impacted by it. Okay, so hopefully that explains what's going to happen. I think I did explain earlier that we won't inform you proactively with one of these emails. Let me go back here. You won't get an email like this one saying there's going to be a 30-second pause on various machines that you've got, because most people aren't even going to notice it. However, if we are going to perform something which is genuinely going to require the power to the memory of your machine gets removed, in other words, the machine has to be shut down, the VM has to be shut down, then you will get an update like this. Apparently so it's now the 24th of March 2017. Sometime this year we're going to perform upgrades it'll be staggered upgrades. We're not going to upgrade every single host at the same time, but staggered upgrades to server 2016. And that might involve your single instance VMs going through a reboot, and it will be planned, and you may well get an email like this, because it may not be possible by the time we get there to perform that kind of an upgrade by using memory preserving updates. Okay, hope that explains it all, and hope you understand it.